Last year, the challenge was from the LA Metro Bike Share to analyze data taken from more than 600,000 bicycle commuter trips made in Los Angeles and develop business solutions for LA Bike Share, a nonprofit company in Los Angeles. So I want to start by saying this might seem unfair that the prompt was pretty much to develop business solutions, but that's really how data science is in the real world. So it's actually a good way to get started. A lot of times in classes, you're given a very specific problem, do a t-test on this problem, or maybe develop a computer vision algorithm to detect if there's a person standing in front of the camera. That's all great in a classroom setting, but a lot of times in the real world, people will just be like, hey, I heard big data is kind of like a thing that we should be doing, do something with it and make our business better. And so being able to do that and map from a problem, just like some data that a company might have, to an actual deliverable solution is one of the best skills you can have as a data scientist. Yeah. Is this the clicker? I get to use a clicker. Hey, cool. So this is last year, we won first place. Chinmay here sitting in the front and I and two others won first place in the graduate division. And Brandon Walker is out at IBM as a data scientist right now. Sheil is a graduate student, PhD. And so everyone's been going on into data science. I mentioned this because I want to just show that the tools that I'll talk to you about tonight, the steps, have been developed over several years. This was the year before that. We won second place as a graduate division. So I've been doing this ever since it started. And from several iterations, these are the steps and tools that have obviously worked in some way or another. So data science can be thought about in an 8-step process. This is actually, the diagram at the top is from Bing Yu, who's a professor at Berkeley. And I really like this diagram that she presented. It goes through about the 8 steps of data science. So the first step in data science is you kind of got to come up with a research question. Like I said before, a lot of times a company will just be, do something good with my data or increase my return on investment. And they might not give you that much more. They might not even give you the kind of data. So you're going to have to map a seemingly endless pool of possibilities to an actual solution that you can deliver on. And so we decided to focus on where should we place new bike share stations in LA City. And to answer that, we had to ask ourselves some sub-questions. How successful are current stations and why? How do people want new, or where do people want new stations and why? So some notes on this is think outside of the box. If you don't come up with a good problem that can be solved through data at the beginning, then no matter how many cool algorithms you come up with, they'll be for naught. Then next is ask a question that should be asked, but maybe people just aren't asking it yet. And also ask a question about what are people spending their time on that could be automated with something that you do, or could be done better with data. And the second step is data collection. So in the case of last year, you're given CSV files, which were the bike trips from one station to another in LA. And a lot of teams used this data and made some really accurate predictions on assets of the data, like maybe how long a trip time would take or things like that. But one of the best things you can do as a data scientist, and the judges told us one of the reasons we won, is because we thought out of the box in collecting new data. And so we went online and collected data from Census, like the income of areas and the population and the ages of people. And we collected weather, we might have collected weather data. That's a pretty common one to collect. And we collected web scrape data from forums, which I'll talk about in a little bit. So nowadays, there's actually really awesome ways to collect external data that have even popped up even since last year. I've kind of been keeping my pulse on it a little bit more. And if you are curious about those, definitely follow us on tammydatathon.com or Tammy Datathon Facebook page. We try to post resources for new exciting like data sources and whatnot, tutorials. But just to give you some examples, there's actually, Google now has an index of data sets. So you can, I forgot what it is, maybe datasets.google.com or something like that, where you can type in the kind of data you're looking for and it will return to you nicely formatted data sets. There's also a lot of census data out there, and so definitely look around and think, how can I augment? You probably will be given some data by TAMIDs, but think about how you can augment that data to come up with a more complete picture. So the bike share was in LA station, in LA City, and so that's that little box down there. That's about where we got our data from. And there was a website that we found, which was actually hosted by LA Metro Bike Share, which was a place where people could drop pins about where they wanted new stations. Not only that, but they could leave comments about why they wanted a new station there. And then other people could either leave, either could drop more pins, or they could click a pin that's already been dropped and like upvote it. So they're like, I also want a station here. So this was a really rich data set, but it didn't come to us in a nice CSV. So we had to do some Python, HTML, JavaScript, and do some parsing of this web page. For one, it was very hard to interact with because you had to, there's thousands of pins here, but you have to click each pin and it has to open up, and then there's several UI steps you have to make to get through all the comments. So for a human to read through all the comments, not only would it not be objective and precise, but it would just take a very long time. So that's a great place for data science to come in. So here's an example of a comment box. So a quote from this comment box was, more transportation options for students getting to school and from school. So it's nice to know, you should have a good idea of kind of what data science can do. If you're not familiar, one thing I've been doing a lot recently is just going on Kaggle and even looking at past Kaggle competitions to just kind of familiarize myself. I've been doing data science for years now, and I still feel like if someone came to me and asked me, what can data science do for me? It would be a little hard for me to give them some exact nice ways data science can help them. So you should be familiar with the kinds of tools that are in your data science toolbox. That doesn't mean you have to understand how they all work, but that's one thing you should do. So one tool that was in my data science toolbox was topic extraction. I might not know exactly how the NLP of topic extraction works, but I know it's out there. So when I saw a problem like this, a comment where there's obvious objectives or nouns in this comment that are more valuable than other words, like maybe students in school, I thought of this object detection or topic detection algorithm. So pretty much after scraping all of these comments, we created ourselves a nice CSV file with the comment and the lat long point and maybe the time it was left. Okay, so now this is a data frame we can work with. Through Python, we hit the API called Dandelion to get the topics out of each comment and add them to our CSV file. From there, that's kind of a lower dimension projection of the comment space, and so we could do better data science on that. Now, when you come to data cleaning, you have to ask yourself questions like how to fill in missing values, how to format your data, and you have to do feature engineering. And for these, I like using Python, Jupyter, and Pandas. A little bit more on that later. But this is really time consuming. About 80% of your time as a data scientist will be spent doing these things. So if this is your first data science competition, maybe don't think that you're gonna spend all your time like building the fanciest machine learning models. And if you are, you actually might be doing it wrong. That's one thing TAMIDs definitely does different than Kaggle. If any of you have played a role in a Kaggle competition, it's solely based on your score in the evaluation criteria. And that has some benefits. It works really well for a non-monitored, judged type of competition where there's no humans involved in the judging contest. But in this case, there are judges involved. And so just because you got a 91% evaluation accuracy versus a 90% evaluation accuracy, your judges probably don't care. We got like, I don't know, 70 or 60% accuracy on our algorithm. But what we did is tell a complete story. And that actually maps to the real world probably better because, yeah, so that's why your feature engineering is probably the most important part of what you do rather than just fitting a extremely precise machine learning algorithm. So if you find yourself spending the majority of your time just fitting a really precise machine learning algorithm, you should probably take a step back and ask yourself if that's what you should spend your time doing. Okay, so for the web scrape data, we took a comment, we just hit an API for extract topics. And that's another thing. The judges, I mean, they do care that you do really cool stuff, but we hit an API for the topic extraction. We didn't take out time to build our own topic extraction algorithm. Maybe we would have gotten some points for that, but we had some other things to do. So use resources available to you. Maybe build an MVP the simplest way you can, minimal viable product, the simplest way you can using other people's code. And then maybe if you have time later, then you can go back and implement the algorithm on your own. But don't spend your time on stuff that other people have done when the real result is your end product. So yeah, we used an API, someone else's code, and it was pretty much an extract topics function that we just got to pass our comment to, and then it would extract, say, students in school. So most data science that we like to do is on CSV files. So if you can get your data if you can map your data to a nice CSV file, that's a good place to start. Oh yeah, so one comment I meant to make on this is, as a data scientist, you do have to we try to be objective as much as possible, scientific, but there are a lot of decisions you make. When you fill in missing data, which you'll probably have, do you fill it in with zeros, with the mean, with the mode, with the median? Do you delete the rows? Do you delete the columns? These are all decisions that you as a human can make better than a computer. And it's fine for you to make these decisions, but you get massive points with the judges if you know that these are subjective decisions you made and then report on them in the final analysis. So you tell them, hey, this was a decision I made, and this is so that they just know that that was part of the conclusion you came to. So the fourth step of data science is evaluation or exploration and visualization. So once you've done some data cleaning, you'll want to visualize your data and make sure you have a good understanding of the data that you're playing with. Maybe you've heard of the mantra of garbage in, garbage out when it comes to machine learning algorithms, but that's so true. If you just try to feed your data, just because it's in nice CSV now, that doesn't mean you can just necessarily feed it to a machine learning algorithm and get good results. And even if you do get good results, that's even a more reason to be a little worried if you haven't done your proper visualization yet. So visualization is a good step before you do machine learning, but it can also be the end of your project. If all you do is some visualization, you're actually probably about 80% to the end of your project. So here's some visualization that we included in our final report. One is a heat map. A heat map is really good if you have two continuous axes, ordered axes, ordinal axes. So in this case, weekday versus hour. The whiteness of a square is how many rides happened in that section, in that area. So what's clear from this first plot is that our bikers seem to be commuters, because there's the most bike rides around 8 a.m. and 5 p.m. on weekdays. The next one is just a linear regression fit to a time series. So obviously the linear regression isn't for prediction, accuracy or anything, but it gives a nice trend to say, hey, look, it looks like the blue is going up. So hey, downtown LA, maybe you should pay some attention to downtown LA. It'd probably be a good place to put some efforts into. Whereas Venice Port of LA hasn't been seeming to go anywhere, and Pasadena seems to be going down. And we actually looked at news articles and found that around the time of this competition, the mayor of Pasadena just passed a law he just announced that because the bike shares weren't doing that well in Pasadena, they were gonna drop off support. And so including stuff like this and stepping back from your data, the numbers, and then getting a good full picture is what you'll need to do in the real world, and so it's what the judges care about. Yeah, so if you saw from those two plots, what I tried to do was convey a message, more so than like just look at the numbers, try to convey a human interpretation. I do believe, this is a little side tangent, but computers are just gonna keep getting smarter and better at doing what they do. And so where data scientists come in and will always come in, the IC is mapping meaning to the results. So a computer can say, hey, there's more riders at 5 p.m. and 8 a.m., but a human would have to then say, So that means you have more commuters, so therefore maybe you should do things that commuters would like to use. You see, mapping meaning to the results is something a data scientist does. So here's some more visualizations of census data. We visualized it in that area. This is a visualization of median age and population density. And this was a visualization that was a big part of our presentation. So this is a word cloud. Remember all those topics that we pulled out of the comments? Well, this is where we used, I think, the only place we used it. And so we wanted, remember that first question is, where should we put new bike stations and why? And through that, we asked that sub-question of, well, where do people want bike stations and why? And this was pretty much the answer to that. So this was a data-driven answer to why people are wanting bike stations that they're wanting. Now, we did make one assumption in making this word cloud and making that claim about this word cloud. That assumption is that all the comments that were left were positive comments, or comments saying, I want a station here because. We don't think anyone would leave a pin to say, I don't want a station here, and then leave some comments, if that makes sense. So we took this interpretation to say that this word cloud should be all the reasons why people would want a station in LA. And why does that matter? Well, if I'm LA Metro Bike Share, I'm gonna look at this and be like, wow, people really care about the Expo line. So let's look at the Expo line that runs through LA and see what places we haven't put stations that we should put stations. Because whoever's commenting and leaving all these thousands of comments, reoccurring topic seems to be the Expo line. One really cool thing about Dandelion too, is it not only extracts the noun, the topic, but then it does even a further dimension reduction to what it thinks that noun is talking about. So it's a little hard to explain if you haven't seen this before, but people could use several words to kind of say the same thing. So if maybe someone said like train line, and maybe someone said like train track or something, it would map all of those to Expo line. And that was another really awesome API that we didn't have to make, but we were able to use to create this kind of word cloud. Because otherwise the dimensionality, even the topic space the noun space would be too large to create a interpretable word cloud. So next is the heat map that we created of the LA bike share activity, comment activity. So remember all those pins way back? Well, from those pins, you can kind of get an idea of where the most pins are left. But remember I told you people could click on a pin and then upvote it. And you definitely don't get that visualization from this. And so where do people are leaving the most pins or upvoting the most pins? And that's what our heat map gave. And so you can very clearly see some areas that many people are leaving pins. And this does a Gaussian density estimate over the pins to create this heat map. But what's really interesting here is this is Culver City. And I'll come back to that in a little bit. Okay, well, the machine learning, the model fitting. So once you've done your visualization, if you think you understand your data, then you can go on to some model fitting. If you don't know any machine learning, I would say just start with random forest. It's able to handle a lot of different kinds of data. It's able to do classification and regression. It's still very accurate. I mean, it's not like where random forest might get like 89, the state-of-the-art algorithm might get like 92 or something. And so random forest has been shown to do very well, and you don't need to know that much. And it's actually very interpretable. So that's a really nice thing about random forest. If you're doing like computer vision or natural language processing, you might want to consider deep networks. So yeah, the focus, if you're on a short time frame, and 5 weeks is pretty short, it's a good time to try to learn, but also at the end of the day, you can just focus on which algorithm should I use rather than like how does each one work. So that's why I'm telling you random forest is a great one to start with. But sklearn is a great place to start with machine learning if you've never done machine learning before. Okay, so this is something really cool that Brandon did on our team, and it's pretty out of the box in my thought process. This isn't your traditional machine learning, but Brandon did Markov chain modeling. And so he took pretty much all the stations, and then so he created a transition matrix for how likely, if you're at a station A, how likely is it that you go to station B, C, and so on. And so you create a transition matrix, a square matrix, that pretty much is your transition probability of if you're at a station, one station, then how likely are you to go to any of the other stations? And then pretty much if you take this matrix and raise it to infinity or a very large number, you get steady state distribution of your stations. And so from that, we were able to say, what's the expected number of bikes at a steady state each station? And we were able to show some stations have an extremely high expected number of bikes. So how does this work? Well, 37 bikes might not always be at these bike stations, unlike bikes here on campus, these bike stations were set stations that you had to park it in, and they could only accept 20 bikes. So these stations, or maybe it was 20 or maybe a little bit less, something like that. Let's say 20. So all these stations which have an expected number of bikes over 20 were stations that had to be rebalanced a lot. People had to come and pick up the bikes and bring them elsewhere. So this was a big cost for LA Metro Bike Share. Whereas these stations down there had very few, and this table is cut. So we're only showing the top most stations and the stations most underloaded. So from that, we can make a business solution to LA Metro Bike Share. And we looked up the closest, there's like a Whole Foods next to somewhere like, so let's say the lowest one, 4135. And let's say for sake of argument, I'm not sure exactly which station it was, but one of the overloaded stations, like say the very top one, where these stations were very close. So we tried to recommend to LA Metro Bike Share to work with Whole Foods to give some sort of coupon to people who used LA Metro Bike Share and then parked at one of those underloaded stations that was very close to the overloaded stations, but for whatever reason, people weren't parking there. So just some extra motivation. So this is one place where, as a data scientist, you might not think that you should branch into those business type recommendations. But that's exactly what you're going to be requested to do in the real world and give application to your numbers. So if we just gave this to a business person, they might not understand the implications of what we are saying. But if we gave them some sort of recommendation like that, they might, at least it might get their brain turning. Another important part of machine learning is your interpretability. And a big part of interpretability is feature importance. So we tried to predict what the station popularity would be. Popularity being how many people are using that station. So we wanted to tell LA Metro Bike Share, our initial question was how many, or where should we put new stations and why? And one of the questions was how popular are stations currently and why, right? That was a sub-question we had to answer first. And so this was in answering that question. So we fit a machine learning, random forest to the target variable was how many rides were coming into station X. And then we collected all these other features about station X. Things like inherited success, which is a feature that we engineered. I won't get into it. Metro distance, the distance to a metro station, total population, non-family percentage, so single people at that station, renter occupancy at that station, median income, median age. So these are all features that after we fit the random forest and got an accuracy of, I don't know, it was reasonable. It wasn't amazing, but it was reasonable. We were able to pull out the feature importance. And that was how much the machine learning algorithm listened to each of the features we gave it for it to be able to predict how successful a current station was. Using these features, we were able to say, these are the features that contribute most to how successful a current station is. So when you think about putting a new station down, you should pay attention to these features. All right, so then we use the same machine learning algorithm, this one, the random forest, to take every station that people suggested. That it was really nice that we had that people suggested list of like, say, 1,000 stations, because that kind of discretized this like Euclidean space of the map, right? And it gave like specific points that we could test we could feed into a machine learning algorithm and then ask our machine learning algorithm, how successful would it actually be if we put a station at this place where a person asked for a station? And from that, we were able to get a ranked list of, for all the stations that people gave us or gave recommendations for, which ones should we actually build based on the success of the past stations, right? And these are the first 5 stations that came out. So 1, 2, and 3 were from downtown LA. Remember that initial visualization we did? downtown LA seems to be growing. So this made a lot of sense to us. And again, it's just so important to visualize and then check your predictions against your intuitions and against your visualizations. But the next one was Culver City, and that one was really interesting to us because it wasn't next to any metro stations, and yet it was still predicted by our machine learning algorithm to be very successful. Remember back to that heat map, there's a lot of heat around Culver City. Interesting enough, right as we released this, Culver City came out with an announcement that they would be the next place that Metro Bike Share was gonna move into. Yeah, so that's, if you can see now overlaid the heat map, you can see that Culver City was one of the places a lot of people wanted stations. So now we have, not only does this have the most predicted success, but it's where people want the station the most. In the last part, you need to update domain knowledge. So, okay, I interpret the result, but so what? Well, these are the 4-step process. Okay, LA Metro Bike Share, like I'm talking to you as if you were the bike share. These are the things I tangibly recommend you do when you leave this room to improve your business model. 1, pay attention to proximity to Metro Expo line, Koreatown, UCLA, bus stops, and bike paths. 2, think about downtown LA. It's popping. Put more stations here. 3, Culver City. Your next big move should be to Culver City. And 4, your user base. Think these, from the data, your user base are young, single, commuting people. So you need to answer so what for them. If you just leave the presentation as so many people do, they just say, look, our machine algorithm got a really high accuracy. Look, we fed it all these features. And maybe that's it. Maybe, yeah, that's often how it's left, which makes sense because maybe at a place like Kaggle that works. But here in TAMIDS, that doesn't work, and in the real world, that doesn't work as a data scientist. You have to end with, so what? Answer that for them. Make it actionable. Like if you were LA Bike Share, you could leave this room and have 4 steps that you could implement today with your team that could, through the data, be shown to improve your business. And 3, all your conclusions must be supported by your data analysis. So all of these things are very based on the data that I've shown you and the analysis we did on that data. All right, so tools. How do you get started if you haven't done much data science before, or even if you have? The things we use are, we used Python, Brandon used R, both are fine. I use the code environment Jupyter Notebook, but I use one called Google Colab, which is a very nice Jupyter Notebook on the cloud. And for data wrangling, I use the package Pandas. For data visualization, it depends what level. If you want to be very high level, don't even want to code at all, you can use Tableau or Google Data Studio. If you want to be mid-level, have some control over your plots, but maybe not a lot, you can use Plotly or Seaborn. And if you want to be real low level and have every control over every inch of your plot, you can use Matplotlib. For machine learning, sklearn is really a great place to start, and will probably be good for about 80% of the stuff you want to do. For presenting, slides, obviously, but something we did that no other teams have done is we actually created a website. I think it was an interactive website where people could go on there and look at the map and actually hover over the points and look at the comments people were leaving, things like that. Also, if I could go back like 2 or 3 years, this is one thing I would change, is you put so many hours, days, weeks, months into creating an amazing project. And then if you just spent a few more hours creating a really nice like README, a really nice like presentation, static website about your project, then that project could live on. But the problem is, so often I just spend months creating that project and then like submitting it and never like putting it online or anything. And then I never feel like going back and like just polishing it to put it on like my portfolio, online portfolio or something like that. So if you could just if you build like a static website or an interactive website that anyone can go with with a link, then that's a great link to put on your resume, and it makes your resume way more interactive. Most of my stuff on my resume now does have like links, but I've had to be very retroactive about that, and that's something I wish I would have done earlier. So a little plug for TAMU Datathon. We think it's awesome that you're doing this. We are super excited because this is kind of like a 5-week competition, which is a great time to learn and get good at data science. If you want a really condensed version of this in the fall, over 2 days, the TAMI Datathon last year had over 2,000 applications from 110 universities worldwide, over 95 majors that you can team up with, over $16,000 in prizes. We had 5 colleges and departments represented there. We had 15 company sponsors that slide didn't make it on, but including Facebook, Walmart, ConocoPhillips, and that took their winners and put them through the interview process for internships and full-time jobs. So yeah, with that, thank you so much for your time. You've been an awesome audience, and I appreciate it. I would like to open it up to questions if anyone has any questions. Yes, Seth.
So when you go back to turn forwards.
Yes.
So why did you this credit? I thought this was like a cool credit. So you trained a model, you got certain accuracy, and you went backwards and found which features were most contributing to that result. Did I understand that correctly?
Yes, we fit a model and then we kind of went backwards and found what features were most contributing to that result. Yeah, these were some of the most important features. I don't know if this was the key. I think this combined with just several of the other things we did. But yeah, this was something we were proud of. Yes, sir. Oh, okay. To repeat the question. I'll do that from now on. Let's see. Yeah. I did mean to mention here, I saw y'all taking pictures. Actually, there's been a full course developed online, free to all of you by TAMI Datathon that covers all of these things. It's on cosmos.tamiDatathon.com. The code, you don't even have to download anything. It's all available. Chinmay over here and I have been working on this for almost a year now, and the Datathon team should keep developing it. If any of y'all know Medium, we're kind of trying to develop it as a medium for data science tutorials, so anyone can go and create data science tutorials, but they're actually interactive code. The cards here, you can actually complete them during the competition, like we gave away t-shirts and stickers and stuff for people completing them at TAMI Datathon, but you can do them at your own pace. But yeah, they go over all of this stuff, Pandas, sklearn, how to even create a data science project, pretty much everything I've talked about tonight, but at your own pace and with interactive code. Any other questions? Yes. Okay, the question was one thing I should change if I was to do the competition this year. Well, from the first year, I think something that was very obvious to me was I didn't use Jupyter Notebook, and we were dealing with like 50 gigabyte files for the taxi competition. This was back in 2018. And so every time we had to rerun our Python script, we had to reload that CSV file that was many gigabytes. And so every iteration took minutes. And I kind of really kicked myself because I knew about Jupyter Notebooks, but I wasn't using it until after the competition. With Jupyter Notebooks, you can run one cell once, like to load the data, and then you have like another cell, and that your data stays in the environment, so you don't have to reload your data, and then you can like iterate on your algorithm on that data or something. So that would have saved me, oh my gosh, hours or days in the first year. In the second year, we definitely waited till the end, which, yeah, I mean, it kind of happens. That's why we are, myself, Chinmay, Allison, are all holding a help session kind of towards the end. So we hope you won't like wait to start till the end, but we know it's kind of crunch time at the end. So we want to be there for you if you run into technical difficulties. That's what that help session is at the end. Let's see, anything else I would change for last year? Chinmay has a comment.
He talked about using Google Colab. The good thing is if your data set is, statically hosted somewhere, you could just use Colab, and that's going to use Google's internet to download all of that data. So you're going to get much faster speeds if you use Colab. And yeah, it's also going to give you free GPUs and stuff. So yeah.
Thank you, Chinmay. And again, Colab is actually what the entire Cosmos is written in. So if you open up any of those lessons, you can even do them on your phone. That's the nice thing about Colab. It runs in the cloud, so you don't have to download anything. Any other questions? Okay, well, good luck to all of you. I know you're gonna rock it, and I wish I could do it again, but I'm gonna be there cheering y'all on. Good luck.